Now we move to a related but different set of questions. This is what we need to understand in order to find the volume of the sphere or the hemisphere. We want a little more detail about the region that lies directly above the delta x by delta y rectangle. We specifically want to know, really, okay, we know that the top of this thing isn't really flat. Okay, we're out here in the first quadrant somewhere, the way I've drawn it. Of course, we could be anywhere. And we know that if we go up to here, the surface isn't flat above this. So even if delta x and delta y are small, so the surface is very nearly flat, it's not parallel to the xy axis, is it? It's tilted in some way with respect to the xy axis. Just take a piece of tile and put it on a basketball in various places, and you'll see that it's not parallel to a horizontal plane through the center of the basketball. Okay. And tennis ball if you don't have a basketball, you know, whatever. Okay. What we're asking then is, if we cut the sphere with a plane parallel to the a plane parallel to the z-axis, passing through the point x star, y star. If we cut it with a plane where y star is constant, then what kind of a shape do we get when we cut it? And what is the slope, or what is a tangent, a vector tangent to that curve at the point lying above the x star, y star point? Okay, well, now you can read the statement of the problem. You're not going to completely understand it if I say it, even if I say it right. Okay, that's, maybe I said it right. Okay, well, here's our picture again. We got our sphere, and here's a plane, y equals y star. Okay, that plane confines us to the line y equals y star down in the xy plane, and that's just a line parallel to the x-axis through our point x star, y star. But then for any z, we still can satisfy y equals y star. No matter what x and y are down here, any z satisfies it, so that gives us a vertical plane, and you should be very familiar with that idea anyhow. So our plane y equals y star is going to look kind of like this. Okay, here is a line through our x star, y star point, which is implicitly here, parallel to the x-axis, and here are the points directly above and below it. So here is a picture of that plane. And it should be clear that that plane is going to intersect our sphere in a circle. And here we've represented half the circle of intersection. Okay. Now here's a front view. We're looking at this from the positive x-axis, along this axis. So the x-axis is really coming directly out of the blackboard toward us. So we're just looking at a two-dimensional view as we would see it from a long distance along the x-axis. So we see the sphere, which just appears to be a circle, and we see our point x star, y star, which is indicated by an x here. And here we have an axis parallel to the y-axis. And actually, is that supposed to be y? Did I really do that? It's kind of an ambiguous symbol. But since y is constant, obviously you don't have a y-axis in this picture. That would be an axis. It's not the actual x-axis. Well, yeah, it could actually be the x-axis. Okay. So we're looking in the plane. Now it couldn't be the actual x-axis, but it's parallel. Well, the axis is just this arrow right here. Okay. So it's parallel to an x-axis. So I'll call it an x prime axis, let's say. And we do have an axis parallel to the z-axis. Maybe I better call it a z-prime axis. Now, how far are we from the origin of this coordinate system? The origin would be right here when we're at this point. Well, think about it. And I think I did something really unfortunate down here, so I'm going to stop and pick up after I correct it.